Hello students, in this video we're going to see how to solve trigonometric equations. Yeah. Okay, before we start solving the problems, let us recall certain basic concepts which you need to know to solve these equations. Okay, as you can see, I have drawn a Cartesian plane. Now if I take theta, if I take an acute angle theta, then theta will lie in the first quadrant, and in the second quadrant we'll have 180 minus theta, and in the third quadrant we'll have 180 plus theta, and in the fourth quadrant we'll have 360 minus theta. Right? I'm writing in terms of multiples of 180. Of course, second quadrant can be written as 90 plus theta, but I'm not going into that. I mean, I'm looking only at even multiples of 90. Okay. Now we all know that in the first quadrant, this is the first quadrant, this is the first quadrant, and this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. In the first quadrant, all trigonometric functions are positive. That means let us confine ourselves to only sine, cosine, and tangent, sine, cos, and tan. So all these three functions are positive in the first quadrant. Now in the second quadrant, only sine is positive. Okay, and in the third quadrant only tan is positive. That means the sine and cosine are negative in the third quadrant, and in the fourth quadrant only cos is positive. What does it mean? That means in the first quadrant, when I say all functions are positive, so if, for example, if I want to find sine 60, it will be sine 60 degrees, it will be positive. If I find cos, let's say 72, you will notice that it will be a positive value. And if you find tan 18 degrees, and it will also be positive, right? So in first quadrant, all these three functions the values of these functions will be positive, provided theta lies between 0 and 90 degrees. Yeah. Now in the second quadrant, only sine is positive. What does it mean? It means now before going into this, let's say what angles will be there in the first quadrant. So we'll have 0 degrees to 90 degrees in the first quadrant. I mean, if we measure in terms of degrees, then we'll have 90 degrees to 180 degrees in the second quadrant, and 180 degrees to 270 degrees in third quadrant, and then 270 degrees to 360 degrees in the fourth quadrant. If we measure in terms of degrees. What if we measure in terms of radians? Then this is how it look like. We'll have 0 to pi by 2, which is nothing but 1.57 radian. Okay. In the second quadrant, pi by 2 to pi, that means 1.57 radian to 3.14 approximately radian, and in the third quadrant it is 3.14 radian to 4.71 radian, and in the last quadrant, the fourth quadrant, it is 4.71 radian to 6.28 radian, right? Okay. Now I mentioned that in the second quadrant only sine alone is positive. So what it means is, let me write it here. Okay, it means if I find sine 110 degrees, it will be a positive answer, it will be positive. But if I find cos 110, it will be a negative value, and same way if I find, let's say, tan 130 degrees, and again it will be negative. So in the second quadrant, if you take any angle between 90 and 180, and if you find the sine value, it will be positive, cos value will be negative, and tan value will be negative. Yeah. Now in the third quadrant, only tan is positive. So it means, let me take an angle in the third quadrant above 180 and less than 270. Let's say I take 220. So if I find sine 220 degrees, you will find that it will be a negative value. Same way, if you find cos of, let's say, 210, again it will be negative. But if you find tan of, let's say, 240, and you will find that it will be a positive value, right? And finally, in the fourth quadrant, only cos is positive here. Um, only cos is positive in the fourth quadrant. So it means if I find sine, fourth quadrant means angle between any angle between 270 degrees and 360 degrees. Let's say sine 300 degrees. It will be a negative value. Cos 300 will be positive, and if I find, let's say, tan 320 degrees, it will be negative, right? Okay, fine. Okay, now let us look at this Cartesian plane. Any angle, if it is mentioned in radian, any angle between 0 and 1.57 sorry, will lie in the first quadrant, and 1.57 to 3.14 will lie in the second quadrant, 3.14 to 4.71 in the third quadrant, and 4.71 to 6.28 in the fourth quadrant. Okay, as I mentioned earlier, all functions are positive in the first quadrant. Only sine function is positive in the second quadrant. Third quadrant, only tan is positive, and fourth quadrant, only cos is positive. The cosine is positive. Okay, so suppose if I want to find, let's say, sine of, let's say, 2.1. Now, as you can see, this 2.1 lies in the second quadrant, so obviously it will be positive. Okay, suppose if I want to find, let's say, tan 1.3. Now, as you can see, this 1.3 lies in the first quadrant, so obviously first quadrant tan is positive. If you want to find, let us say, I'm writing to the left hand side of the screen. Let's say I want to find cos 4.2. Now, as you can see, 4.2 lies in the third quadrant where cos is negative, so cos 4.2 radians will be negative. And finally, let's say I want to find cos 5.1 radian. Now again, 5.1 lies in the fourth quadrant, so where cos is positive, so cos of 5.1 will be a positive answer, right? Okay, now let us look at the angles in the second quadrant. Now we know that sine of 180 minus theta will be same as sine theta. So what does it mean? It means sine of 120 degrees, which can be written as sine of let's say 180 minus 60, which is equal to sine 60. So sine 120 degrees and sine 60 degrees will be equal. In fact, both of them are equal to root 3 by 2. Yeah, and you can notice one thing: 120 degrees and 60 degrees are supplementary. That means they add up to 180 degrees. So if you add 120 degrees plus 60 degree, you will get 180 degrees. Now, using this property, I'm not going to teach you in this video how this came up. This how come sine 180 minus theta is sine theta? Why not minus sine theta, or why not cos theta? Because you don't have the time for that. So please learn that sine of 180 minus theta is sine theta. So what I mean is sine 100 degrees and sine 80 degrees will have the same value, because 100 and 80 will add up to 180. Same way, sine 170 degrees and sine 10 degrees will be equal in value, because 170 and 10 will add up to 180 degrees. So in case if, let's say, sine 100 degree is P, and if they ask you what is the sine 80 degrees, it will also be equal to P, because sine 80 degrees is equal to sine 100 degrees, so sine 80 degrees will also be equal to P. Yeah, so this is a very, very important property. Sine 180 minus theta equal to sine theta. They have the same value and the same sign. Now cos 180 minus theta, 180 degrees minus theta will be equal to minus cos theta. So it means cos 100 degrees will be equal to minus cos 80 degrees. Again, as you can see, 100 and 80 add up to 180 degrees. And cos 60 degrees will be equal to minus 120 degrees. And let's say cos 170 degree will be equal to minus 100, cos of 10 degrees, right? So according to this property, we can write this. If you want to cross check, you can check. Let's say, for example, cos 60. Cos 60 degree I know is half, isn't it? Same way, if I want to find cos 120 degrees, it is minus half. So as you can see, cos 60 and cos 120 degree, they have the same numerical value, but they differ by sign. Cos 60 is plus half and cos 120 degrees is minus half. Okay. So let's say, for example, in a problem, if they are given cos 70 degrees is equal to Q, and if they ask you what is the value of cos 110 degrees. Now we know that 110 and 70 add up to 180 degrees. So obviously they have the same numerical value but opposite sign. So if cos 70 is Q, obviously cos 110 degrees will be equal to minus Q, right? I hope you have understood till now. Okay. Now, like cos, tan 180 minus theta will also give you minus tan theta. So it means tan 100 degrees will be same as minus tan 80 degrees. Or you can also write it as tan 80 degrees will be equal to minus tan 100 degrees. And tan, let's say 160 degrees will be same as minus tan 20 degrees. You can see that 100, 80, 80, 100, 160 and 20 add up to 180. It's very, very important that they add up to 180. Then only you can use this property. Now, this is the next property. Sine of 180 plus theta will be equal to minus sine theta. Okay, and I'm sorry, I think it's better that before I go ahead, let us recall what we learned earlier. Sine of 180 minus theta equal to sine theta, and cosine of 180 minus theta is minus cos theta, and tan of 180 minus theta equal to minus tan theta. Okay, this is very, very important, so please keep this in mind. Okay, let us look at this now. Sine of 180 plus theta equal to minus sine theta. So it means as you can see, the difference between this 180 plus theta and theta is nothing but 180 degrees difference, not the sum, the difference. Okay, it means sine 200 degrees will be equal to minus sine 20 degrees. As you can see, the difference between 200 and 20 is 180 degrees. Okay, so sine let's say 240 degrees will be equal to, I hope you can guess. So what should I write here so that the difference is 180? Yeah, I should write 60 degrees. So sine 240 will be equal to minus sine 60. So same way, sine let's say 210 degrees will be same as minus sine 30 degrees. Okay, you can see that the difference between 210 and 30 is 180 degrees. Yeah. Okay, now cos of 180 plus theta will be equal to minus cos theta. So which means cos 200 degrees will be equal to minus cos 20 degrees, and cos, let's say 260 degrees will be equal to minus cos 80 degrees, and let's say cos, let's take 250 degrees will be equal to minus cos 70 degrees. You can see the difference between 220 is 180. Difference between 260 and 80 is again 180, and the difference between 250 and 70 is again 180 degrees. So what it means is, if let's say cos, let's say 20 degrees equal to P, and if they ask you what is the value of cos 200 degrees, you can see that the difference between 220 is 180. So obviously cos 200 degrees will be equal to minus cos 20 degrees, so which is equal to minus P, right? Good. Now tan 180 degrees plus theta will be equal to plus tan theta. Unlike sine and cos, it is plus tan theta. So it means tan 210 degrees will have the same value as tan 30 degrees, and tan 240 degrees will have the same value as tan 60 degrees, and tan 200 degrees will have the same value as tan 20 degrees. Again, if you notice, the difference between 210 and 30 is 80. 240 and 60, the difference is 80. 220, the difference is 80 again. Yeah. So let us recollect what we learned. Sine of 180 plus 180 degree plus theta will be equal to minus sine theta, where theta here is an acute angle. Cos of 180 degrees plus theta equal to minus cos theta, and tan of 180 degree plus theta equal to plus tan theta. Now let us look at this. Sine of 360 degree minus theta will be equal to minus sine theta. What it means is, sine, as you can see, the difference between the 360, this angle and this angle add up to 360 degrees. So what it means sine 300 degree will have the same value as minus sine 60 degrees. You can see 360 add up to 360, and sine 340 degrees will have the same value as minus sine 20 degrees. As you can see, 340 and 20 add up to 60. Now here, cos of 360 minus theta is cos theta. So it means cos of 300 degrees will have the same value as cos 60 degrees. Okay, it's positive. And finally, you have tan of 360 minus theta is minus tan theta. It means tan of, let's say, 280 degrees will have the same value as minus tan 80 degrees. As you can see, 280 and 80 add up to 360. Okay, now let us look at this. First quadrant we have theta, second quadrant 180 minus theta, third quadrant 180 plus theta, and fourth quadrant 360 minus theta. So let us take the standard angles. The standard angles are 30 degrees. Okay, first let me consider 30 degrees first. So if I take theta as 30 degrees, then second quadrant will be 180 minus 30 is 150 degrees, and 180 plus theta in the third quadrant, so 180 plus 30 is 210 degrees, and in the fourth quadrant 360 minus 30 it is 330 degrees. So this 30, 150, 210 and 330 will form a group. Now what does it mean? It means sine, let's say for example sine 30 degree will be equal to half. We know that. And sine 150 degrees will also have the same value, numerical value is half, so it is half. Now we know that in the second quadrant sine is positive, so it is plus 1 by 2. Now if I want to find sine 210, it will have the same numerical value as, only thing is it will have different sign, but it will be minus half, right? And if I want to find, let's say, sine 330 degrees, again it will be equal to minus half. The absolute value will be same, but it will have different sign. So sine 210 and sine 330 will have the same absolute value as sine 30 degrees, but it will have opposite sign. Okay, that is what I mean when I say it forms a group. So 30 degrees, 150, 210 and 330 degrees. Now let us take next standard angle, let's say 60 degrees. So first quadrant is 60 degrees, second quadrant is 180 minus 60 is 120 degrees, third quadrant is 180 plus 60 is 240 degrees, and fourth quadrant is 360 minus 60 is 300 degrees. Again, these four angles form a group. Okay, fine. Now let us recollect what we learned. 30 degrees, 150 degrees, 210 degrees and 330 degree will form a group. 45, 135, 225 and 315 degrees will form a group. 60, 120 degrees, 240 degrees and 300 degrees will form one group. Yeah, you have to remember this. Okay, now I've seen many students, many of my students struggle when I ask them, for example, what is the value of cos 0? They think a lot. They think whether is it 0 or is it 1 or is it minus 1. Now you should definitely know it by heart. I mean, yeah, I do say that you have to memorize it, but it is, you can always, there are always ways to, I mean, even if you do forget, there are always ways to remember those values, but still you have to, and I'm sure that it's not that tough to remember these values. So let's say 0 degrees. We know that cos 0 is 1, sin 0 is 0 and tan 0 is 0. And if we take 90 degrees, then cos 90 is 0, sin 90 is 1 and tan 90 degrees is not defined. Okay, we don't say infinity but not defined. And okay, if we take 270 degrees, then cos 270 degrees will be equal to minus 1, sin 270 degrees will be equal to 0 and tan 270 degrees. I'm sorry, I think I made a mistake here. I'm really sorry. I'm talking about, so tan cos 270 degrees will be actually 0, not minus 1, and sin 270 will be equal to minus 1, and tan 270 degrees, again it is not defined. Okay, and in fact I was planning to, instead of 180 I mentioned 270 here. Now let us look at 180 degrees. 180 degrees, cos 180 degrees is equal to minus 1, sin 180 degrees will be equal to 0 and tan 180 degrees will also be equal to 0. And finally 360 degrees, cos 360 degrees will be equal to 1, sin 360 degrees will be equal to 0 and tan 360 degrees is again equal to 0. Yeah, okay. So now that we have covered the basics, we have gone through the basics, let us look at trigonometric equations. Now what do you mean by trigonometric equations? Now for example, look at this, 2x plus 1 equal to 5. Now this is a linear equation, we know that. If I write this as, let's say, 2 sin x plus 1 equal to 5, then this becomes a trigonometric equation. Let me consider a quadratic equation. Let's say x square plus 2x plus 5 equal to 0. Now this is an algebraic equation. This is actually a quadratic equation. But if I write it like this, sin square x plus 2 cos x plus 5 equal to 0, then this becomes a trigonometric equation. So a trigonometric equation is nothing but an equation involving a trigonometric function, sine, cosine or tangent. Now how do we solve them? Let us see. We're going to see almost close to 30 problems Some of them we'll do it in this video, and the rest of them we'll do it in another video. Okay, I'll name it as trigonometric equations part 2. So let us start solving them. Okay, now this is the first problem. Now the first few problems I'm going to consider the interval between 0 and 360 degrees. I'm going to restrict the domain for simple reason. For example, if we just say, give you sine x equal to half, then this equation, this trigonometric equation, has infinite solutions. Okay, I mean it can go on and on and on. So we have to restrict them. So I have given only between 0 and x is an angle between 0 degrees and 360 degrees. Okay, now let us look at this equation. Sine x equal to half. Now we know that sine 30 degrees is equal to half, isn't it? So obviously one value of x is 30 degrees. So x equal to 30 degrees. Okay. Now, is there any other angle between 0 and 360 for which sine value will be half? Definitely. Now let us recall, I told you earlier that 30 will form a group with 3 more angles. What are they? One is, if 30, 150. So how did you get that 150? Very simple, 180 minus 30. Okay, and third angle is 210, and fourth angle is 330. Okay, so this is nothing but 180 minus 30, the second quadrant. This is nothing but 180 plus 30, the third quadrant, and this is nothing but 360 degrees minus 30 degrees, which is in the fourth quadrant. Okay, now we know that this is in the first quadrant, and this angle is in the second quadrant, this angle is in the third quadrant, and this angle will be in the fourth quadrant, isn't it? And we know that sine is positive only in the first and second quadrant. In the third and fourth quadrant, it is negative. Now here, sine x equal to half, which is a positive value. So obviously, the second answer will be 150 degrees. So sine x equal to half means the solutions are, that means x can take the value of 30 degree or x can take the value of 150 degrees. Yeah, this is how we do it. Okay, let us go and let us see the second problem now. Okay, now look at this problem. Cos x equal to 1 upon root 2. Now all these problems that we're going to do right now, almost close to 30 problems, are all non-calculator questions. Okay, you're not supposed to use calculator for these equations. Cos x equal to 1 by root 2. Now we all know that the value of cos 45 degrees is 1 upon root 2. So one value of x is 45 degrees. Okay. Now let us see what are the angles associated with 45 that make a group with 45. So one angle is 45. Second angle is 180 minus 45, which is 135. And the third angle is 180 plus 45, which is 225. I'm sorry, 225. And the fourth one is 360 minus 45, which is 315. Now here cos x is 1 by root 2, which is actually a positive value, and we know that cos is positive only in the first and the fourth quadrant. Now this 45 belongs to the first quadrant, and fourth quadrant is 315. Therefore the other solution is 315 degrees. So what it means is cos 45 will be 1 by root 2, and cos 315 degrees will also be equal to 1 upon root 2. Yeah, this is how we solve the problem. Okay, let us look at this problem now. Tan x equal to root 3. So what values x can take? Now we know that tan 60 degrees is equal to root 3. So x, one value of x is 60 degrees. Okay, now there is another value of x which will give me root 3 as the answer. So let us identify that particular value. Now let us look at what are the angles associated with 60 degree. Second quadrant it is 120 degree, 180 minus 60. Third quadrant it is 180 plus 60, so which is 240 degrees. And the fourth quadrant is 360 minus 60, which is 300 degrees. Now since tan x is here a positive value, and we know that tan is positive in the first and third quadrant, so 60 is one answer, and third quadrant 240 is the second answer. So 240 degrees. So for this equation the solutions are 60 degrees and 240 degrees. Okay, now let us look at this problem now. Sin x is equal to minus root 3 by 2. Now I would strongly recommend that if you have understood how to solve. Maybe you can pause this video, solve it on your own, and then after that you can continue playing this video and then check whether your answer is correct or not. Okay, sin x equal to minus root 3 by 2. So as you can see here, the value of sin x is negative, which means that x has to be an angle in the third and fourth quadrant, isn't it? Because sin is negative in the third and fourth quadrant. So x has to be an angle between 180 and 270, the third quadrant, and 270 and 360, the fourth quadrant. Okay, how do we find that angle? These two solutions. Very simple. Now ignore this minus sign and let us consider sin x equal to root 3 upon 2. We know that sin 60 degrees, sin 60 degree equal to root 3 by 2. Let us see what are the angles associated with 60. So we know that one is 60, 120, 240 and 300. Now since here sin value is negative, it has to be in the third and fourth quadrant. So the answers are 240 degrees and 300 degrees. Very, very simple. Yeah. Let us look at another problem. Problem number 5. Let's say cos x equal to minus half. Okay. Again, we know that cos x equal to minus half means x has to be an angle in the second and the third quadrant, because cosine is negative in the second and third quadrant. And okay, let us ignore the minus sign now. Let us consider only cos x equal to half. We all know that cos 60 degrees is half, so obviously again the same, these 60, 120, 240 degrees and 300 degrees. Okay, now since cos is negative here, it has to be in the second quadrant and the third quadrant. So the solutions for this trigonometry equation are 120 degrees and 240 degrees. Very, very simple. Yeah, let us see one more problem involving tan. Okay, look at this. Tan x equal to minus 1 upon root 3. Okay, so obviously it means we know that tan is positive in the first and third quadrant, but here tan x is negative. That means x has to be a value between, it has to lie in the second and the fourth quadrant. Okay, so now again ignore the minus sign. Tan x equal to 1 by root 3. Now we know that tan 30 degrees, tan 30 degrees is equal to 1 upon root 3. So obviously let us consider the four angles associated, including 30, associated with 30. So let's say 30, 150, 210 and 330 degrees. Now since tan is negative here, so it has to be, as I mentioned, second and fourth quadrant, so 150 degree and 330 degrees. So the value of x can be either 150 degree or 330 degree. Okay, so this is how you solve this particular equation. Okay, now before we progress further, students, you need to know some more properties of negative angles. Sine of minus theta will be equal to minus sine theta. So it means sine of, let's say, minus 60 degree will be equal to minus sine 60 degrees. Okay, sine of minus 90 degrees will be equal to minus sine 90. So if they ask you, okay, let's say find the value of sine of, let's say, minus 30 degrees. So sine of minus 30 is nothing but minus sine 30, and we all know that sine 30 degree is half, so minus half. So sine of minus 30 degree is equal to minus half. Okay, let's keep it here. Next one is cos of minus theta is equal to cos theta. Not minus cos theta, but just cos theta. It means cos of minus 60 degree will be same as cos 60 degree. Cos of minus 10 degree will be same as cos 10 degree. Cos of, let's say, minus 25 degree will be same as cos 25 degree. It doesn't matter. And finally, tan of minus theta will be equal to minus tan theta. So it means tan of minus 20 degree will be equal to minus tan 20 degrees. And if you want to find, let's say, tan minus 45, tan of minus 45 is nothing but minus tan 45 according to this property, and we know that tan 45 is 1, so minus 1. So tan of minus 45 degrees is equal to minus 1. Okay, now why am I recollecting these properties? Let us you will need them in the following problems. Okay, let us say, for example, if I extend the domain, if I say that x can be any angle between minus 360 degree and plus 360 degree. Okay, so let us solve some problems. Let us say sin x equal to half. Okay, now what are the angles associated? Okay, what angle will give you half? We know that sin 30 will give you half. So 30 degrees, 150, 210 and 330 degrees. Okay, so since sin x is positive here, so obviously it has to be in the first and second quadrant. So x is 30 degree, or it can be 150 degree. But we also know that sine 210 is minus half, isn't it? We know that sine 210 degrees is nothing but minus half. So it means sine of minus 210 will be equal to plus half, isn't it? Because we have this property of what is the property? Sine of minus theta is minus sine theta. So sine of minus 210 will be definitely equal to 1 by 2. So that means minus 210 can also be a solution. And again, sine of minus 330. Okay, let me write it here. Sine of minus 330 is nothing but minus sine 330, right? According to this property, sine of minus theta is minus sine theta. So minus, now we know that sine 330 degrees is nothing but minus half. So minus of minus half, which is equal to again plus half. Oh, that means minus 330 degree can also give you the, will also give you the value of half. So minus 330 degrees. So for sin x equal to half, these are the four solutions: 30 degrees, 150 degrees, minus 210 degrees, and minus 330 degrees. You might wonder, sir, why not minus 30? I mean, is minus 30 not a solution for this? Let me check. Okay, let me check. Minus 30. So sine of minus 30 is nothing but minus sine 30, because sine of minus theta is minus sine theta, which is nothing but minus half. So sine of minus 30 is minus half, but I have plus half here, isn't it? Not minus half. So obviously minus 30 degrees is not a solution for this trigonometric equation. Okay, let us solve one more problem. Let's say sine x equal to minus root 3 upon 2. Okay, now we know that root 3 upon 2, we'll get root 3 upon 2 when it is sine 60. So 60 degree, 120 degrees, 240 degree, and 300 degree. Okay, that means x has to be, since sin x is positive here, it has to be in the third and fourth quadrant. So 240 degrees and also 300 degrees. Okay, but can x take minus 60? Let us check. Sine of minus 60 is minus sine 60, which is nothing but minus root 3 upon 2. So definitely here minus root 3 upon 2 we have it. So definitely minus 60 degrees can also be a solution, and similarly minus 120 degrees can also be a solution for this trigonometric equation. Okay, let us solve one more problem. Cos x equal to 1 upon root 2. So let us find. So we know that x can take the value of 45. So what are the four angles? Three other angles associated with 45: 45, 135, 225, and 315 degrees. So since cos x is positive here, it has to be in the first and the fourth quadrant. So 45 and 315. And since cos of minus theta is same as cos theta. So it means minus 45 will also be a solution for this equation, because let me check. Cos of minus 45 is cos 45, which is equal to 1 upon root 2. So minus 45 is also a solution. Similarly, minus 315 will also be a solution for this trigonometric equation. Okay, fine students, I am stopping it here. So what I'm doing, I'm going to solve the rest of the problems in the part 2 of this video. So I hope you've learned something by watching this 40-minute video till now, and so I'll see you in the next video, students. Thank you.